Factoring Day 4. Today we're going to take another look at trinomials and I'm going to upgrade them. So for Day 4, we're going to have trinomials where a is bigger than 1. So that's going to look like this. We have ax squared plus bx plus c, or if we're in quadratic form, ax 2p, bxp, and c. Remember, that just means that your first exponent is twice as big as your second. Okay, so I'm going to take a look at examples today, kind of like what we did yesterday, where we are going to consider example and write down the steps that we would need in order to factor it. So our first example, we have 4x squared minus 7x minus 2. Our first subset, our first sub-step is to check for that GCF, okay? There isn't a GCF in this problem, so now we need to set up an altered x. So we're still going to use x method. The altered x this time is that at the top of my x is going to be a times c, and the bottom of my x is going to be b. So when I look at this example, 4 times negative 2 is negative 8, and then I have negative 7. Two numbers that multiply together to give me negative 8 and add to give me negative 7, negative 8, and positive 1. From here, this is where things are going to get a little different. You're going to have to substitute the circled numbers, so negative 8 and positive 1. We're going to put them in for the negative 7x that I have highlighted in green. So our problem becomes 4x squared minus 8x plus x minus 2. Now we've become a 4-term polynomial, just like yesterday. So we're going to treat it just like yesterday. We're going to group. So group the first two, group the second two, take out a GCF in the first group, so I have 4x, x minus 2. Take out a GCF in the second group, it's positive 1, x minus 2. Double check that you're on the right track. I am good to go. And then write my resulting binomials. So I have x minus 2, 4x plus 1. When you get here, it's always a good idea. Double check for dots. Okay, so those are my steps. So let's take a look at this again. This time we're going to have f of x is equal to 2x to the 4th plus 7x squared plus 6. Always check for that GCF. There isn't one, but this problem's a little bit different since my exponents are bigger. This one's quadratic form. Set up your x method. 2 times 6 is 12. And then we have 7. Two numbers that multiply together to give me 12 and add to give me 7 are 4 and 3. Substitute those in. So I have 2x to the 4th plus 4x squared plus 3x squared plus 6. Notice how I am matching up the exponents that I'm substituting with the middle exponent. Once you have 4 terms, group, just like we did yesterday. So in my first group, I'm going to take a 2x squared. In my second group, I'm going to take out a 3. My binomials that are left over do match. They are x squared plus 2. That's your check. Then write your resulting binomials as your answer. X squared plus 2, 2x squared plus 3. Remember, it's always a good idea to check for dots. Let's do this a couple more times. Example 3, f of x is equal to 4x to the 4th minus 2x squared minus 2. This time, we do have a greatest common factor. It's 2, so let's take it out. So now I'm going to have 2x to the 4th minus x squared minus 1. Let's set up our x. 2 times negative 1 is negative 2, then we have negative 1. Two numbers that multiply together to give me negative 2 and add to give me negative 1 are negative 2 and 1. Substitute them in. Make sure you're keeping the power the same as the middle power. So see those 2's I just highlighted? That's what I mean. Now we have 4 terms, so group. First group has 2x squared in common. So then I'm left with an x squared minus 1. Second group only has a positive 1 in common. So left over is x squared minus 1. Good thing those binomials in blue match, because that tells me I'm on the right track. Now we're going to take our GCF and the resulting binomials. Notice I didn't write it in red. That's because this one had a hidden dots. The square root of x squared is x. The square root of 1 is 1. So now we have 2, x plus 1, x minus 1, 2x squared plus 1. I told you, check for dots. This is a really good time after you see example 4 to take a pause and try the problem on your own, then press play again to see if what you get matches mine. Okay, so there is no greatest common factor here. Okay, and as this goes on, I'm going to kind of discuss this in terms of the think it through that we did yesterday. What's nice about this type of factoring is it still follows the think it through. The only difference is the X method has a little bit of a tweak. So no matter what, if you have 3 terms and it's in quadratic form, you should be doing X method. Happy practicing!